How are you doing, Miss Davis? Miss Davis, you there?
Yes, I'm here.
How are you doing?
I'm doing okay. How are you?
Can you mute yourself from the background? I'm hearing some background music. Thank you. It's only you right now. Let's wait for about 10 more minutes, see if others will join us, then we can begin the class, okay? Can you hear me, Ms. Davis? Ms. Davis, can you hear me? Okay. Let me send a message so that they will know that the class has begun. So somebody else joined us, Miss Owututu. How are you, ma'am?
I'm good.
Yeah.
How are you, sir? Good. How was your Thanksgiving?
Oh, good. How about yours?
Good, good. So when is the project due?
Project.
Yeah.
Let me go to your class again. Well, normally I accept the project last day of class. Even if it's due any other day, I will move the due date to the last day of class. Okay.
Okay.
I think we are three now. So others can join later. We can begin the class. Okay, Mary is here. Mary, can you hear me, Mary?
Yes, Professor. Good afternoon.
How are you today?
Good.
So let us. I think. Is it 10 minutes yet? Miss Davis, you there?
Yes, I'm here.
The last time we spoke, have 10 minutes passed yet?
7 minutes.
7 minutes. Okay, let's wait 3 more minutes. See if other people will join us. If they're done, then we begin. We don't have much time. They can join us later. So this week, I'm sure you guys get the messages I just sent this morning about the last day of class for this semester.
Yes.
Yeah, so it's and last class will be next Saturday. Then the following week will be the final exam week. And the final exam is on the 19th. That's the day. I'm gonna I'll put it on in Canvas for you. I'll open it. It's there already. I'm just gonna open it on Friday night so that you have you can take it's a 2 hours exam, I think. So you can decide to do it by midnight.
How many questions? You say it's due?
On Saturday.
Next Saturday?
19th. So I'll open it up on the Friday night.
What question is it, Professor?
About 10-15 questions.
Okay.
And when I open it up, then you can decide to do it. I'm going to open it up by midnight Friday. Well, when it's midnight, it's already Saturday. So open it midnight in the morning, let's say 3 a.m. because it's the final exam. So you have to, there's a set time for it.
Professor, can you please open it like 12 noon, please?
No, Saturday?
No, I mean in the middle of the night.
No, I can do that.
Like 1 a.m.
1 a.m. I can do that. Yeah.
Thank you.
So then you can finish. You can take it. It's 2
Professor,
hours.
do we have to do it on that same Saturday?
Yes, you have to. 11:59. So
why don't you give us some heads up, like 2 days, maybe post it on Thursday, then we finish doing it on Saturday.
But this is final exam. This is a different rule. So I have to go by the rule.
Oh, okay.
Yeah. The school says it has to be done on that same exam. And the school fixed the timetable. We just go by it. Okay.
Oh, okay.
The only flexibility I have is to like Miss Mary asked to make it available by 1 a.m. on Saturday. That's the kind of set. So if you start it, you have to finish it. So if you take it when you are already prepared, if you don't want to take it in the morning, you can wait later in the day, prepare. Because when you open it and start it, you have to finish it by the set time. Okay. It's not something that is if it's not something that is strange. There are things that we have covered in this class, so no surprise here. Okay. Okay.
Okay, Professor.
So Ms. Davis, are you clocking us? So it's 10 minutes now, right? Ms. Davis, you there? Ms. Davis, can you can you mute yourself on the background so that we can begin? So now I think 10 minutes have passed. Today we'll be working on hypothesis testing. We'll be doing correlation next week. Next Sunday, hypothesis testing. Testing. Now, when we talk about hypothesis in statistics, when we say hypothesis, it means we're talking about a claim. Let me make this big. I'm gonna make it big so you can see. Okay, somebody else joined in this bit. So I'm gonna make it a claim about a population parameter. So any claim we make, that claim may be true or not, but we make the claim and then we test the claim to see if it is correct or not. Okay. So that test of the claim that we make about a population parameter is what we call hypothesis testing statistics. Now, if you remember this, recently they found the vaccine for COVID-19. How did they do that? They make a claim, hypothesis, and then they test it by doing clinical trials. Now they figured out that this medicine can, the claim might be that on average, this medicine can increase the average number of people who recover or who are protected from COVID-19 after taking this vaccine is this. Then the opposite claim with that it is less than that. And then they can now test the claim. Anyway, so when we talk about population parameter, we're talking about the mean, standard deviation, proportion, and so on and so forth. For this class, we're just going to do hypothesis testing for the mean. We're not going to do proportion at this level. Okay, so what we do, we make a claim, then we now investigate the claim by collecting data and then analyzing data. And then we perform the tests that we want to perform, and then we reach a conclusion. So that's what we do in hypothesis testing. Some of the questions we ask when testing hypothesis are follows. Different kind of questions. I just get three of them, only three of them, so you can see what I'm talking about. You can say, does a particular medication lower patient's blood pressure? Does it? We don't know. So we just say, Then, okay, somebody else joined. Carrington. Small. You can also ask, does seatbelt reduce the the severity of injuries caused by accident? Well, we collect a sample and test that. You can say, okay, if you're doing hypothesis testing for the mean, you can say, okay, the average number of people that suffered severe injury is lower when they use seatbelt, and then you can say, okay, there's no change. But then you can now test the claim. Then, does the public or customers prefer certain color in a new line of fashion? So all kind of questions we can ask, and then test the hypothesis from those questions. Now, we have two types of hypothesis that we test in statistics. Two types. The first one is one we call the null hypothesis. Null hypothesis is a statement that the value of the parameter, again, when we say parameter, we mean mean, standard deviation, proportion, So we can say that the null hypothesis say that the parameter have a certain value or equal to something value. It always comes with some kind of equality. So that means the symbol we normally use symbols we use for null hypothesis. Now, see, null hypothesis, the abbreviation is HO. But so for null hypothesis, we use these symbols. We use symbols like equal sign. Okay. I have equal sign here. Excuse me. Symbols like equal. Can you see this? You can all see the screen, right? Hello.
Yeah.
You can also use less than or equal to, greater than or equal to. Some kind of equality we use for null hypothesis, because it is saying that the parameter or the value of the parameter assume some claimed value. So you cannot use less than or greater than in a null hypothesis. Okay. Now, for the alternative hypothesis, when null hypothesis says something, The alternative hypothesis say the opposite of that. See? So that's why we say that it is the alternative, which we use H1 to represent, says is a statement that the parameter has a value that is different from what the null hypothesis say. So for that, we use these symbols, not equal to, okay? I'm gonna put it here. The symbols we use for the alternative hypothesis, alternative, which we represent with H1, okay, is as follows. Equal, not equal, less than, sorry, greater than or less than. We cannot use this, any of this in the null. Similarly, we cannot use these symbols in the we have in the null in the alternative. Any questions on this? Any questions? Good. So
wait, you're saying those are the symbols you can't use in each one?
These ones that I have here are the symbols you can use in the null, but you cannot use them in the alternative. Now, this one here are the symbols you can use in the alternative, and you cannot use them in the null. Okay. So what I have here are the symbols that you can use for each type of hypothesis. Okay.
Okay.
Now, you know that in the test, if you remember the if you listen to news, these vaccines they found against for COVID, they say that those companies say that some say that they are 95%, that vaccine is effective 95% of the time. Am I right or wrong? Am I right or wrong?
Right.
Yeah. That means the chance of that vaccine not working is only 5%. See? So why? Because there's always chance for human error. So what kind of error do you have when we test hypothesis? Well, we have two types. Types 1 error and type 2 error. Okay? Type 1 error and type 2 error. Now, type 1 error is the occurs when we reject null hypothesis when it is true. That means we have committed type 1 error. And type 2 error occurs if we do not reject null hypothesis when it is false. Now, let me show you an explanation. Or let me use a real life situation to explain this. Hypothesis testing scenario can be like, anybody here been to jury trial before? Have any of you been to jury trial before?
No.
Why not? What's that?
No. I don't know. Well, I haven't been to a jury trial.
Well, but any court trial for that matter. Excuse me, I think I need to fix something here. Any court trial, the hypothesis testing scenario can be likened to that. Okay, let me make it a little bit, and I will use the jury trial to explain it so you can see when we say type 1 error, type 2 error, or null hypothesis. It might sound strange. So I'm going to use this decision matrix to explain it. So I will use the jury trial. You can use other things. You can use medication. You can use even a battery of a car being effective. So I'm going to use the jury trial in this case. Same. All right, so not innocent. I would say guilty. Let me put guilty here. Okay, I'm going to use let me put the matrix. Okay. All right. I'm going to adjust this. Adjust this. Okay. And then adjust 2 of this. Okay. HO false. Innocent guilty. Then I would say reject. Okay, let me see what I'm gonna. I'm trying to put some word here, but maybe I'll need to put a line on it. Okay, let me put a line so it will allow me to. Okay, you know what I'm gonna do? Yeah. Okay. And let me move it a little bit. The left to the right. And I'm gonna move that. Okay. So we have reject HO. It means convict. Okay. Do not reject HO. It means acquit. So just give me 1 minute. Let me put this together so we can now discuss that. All right. I think okay. So I say that the two errors we have, type 1 error, it occurs if we reject the null hypothesis when it is true. Type 2 error is if we do not reject the null hypothesis when it is false. And I say I'm going to use a jury trial to explain this. Now, in a jury trial, I'm going to color this, make them blue. Yeah, so sorry. I made this blue. Blue. Okay. Made this one blue. Good. Now, in a jury trial, there are 4 scenarios. The defendant is guilty. The defendant is not guilty. Convict defendants, or do not convict defendants. In any trial, though, any court trial. Now, so our null hypothesis here can be HO that the defendant is innocent. Okay. Yep, it's innocent. Then the alternative, H1, the defendant is guilty. So I can put it in this form, HO, the defendant is innocent. And H1, the defendant is guilty. So the prosecutor or the state attorney, or whatever they call them these days, we come and present the case. If it's an let's say armed robbery, for example, present the case. So that means armed robbery is a crime against the state. So the state attorney will come and present the case to the jury. Now, the defendant's lawyer will come and present their own case to the jury. Okay. Now, whether the jury will say that the defendant is guilty or not depends on the evidence they have. So most times they have enough evidence. That means that the defendant is guilty. They can now convict the defendant. Sometimes when they convict the defendant, it might be an innocent person, but because of the weight of evidence, if the state attorney can bring so much evidence, they might even still convict you, even though you may not commit the crime. I mean, it happens. It doesn't happen all the time, but sometimes it happens. If you have been listening to the news, you will see some people convicted and they stay in jail for like 30 years, and later on, the DNA now prove them innocent. You see that all the time. So the bottom line that conviction is based on the weight of evidence. Sometimes somebody who is guilty will be left go because the evidence is not strong enough. And I give you a more example. See, for example, that's why if you have a private lawyer is not paid until he did do the job he won't get the full payment, or anyway, not that he won't get the full payment, but they charge you a lot because they are ready to dig down, do the investigation. That is their job, to prove, to get you out or make, So if they can't do that, they can't make money. So that's why they are ready to charge you, but they will do all kind of digging. But the state, what they call it, public defender, well, they pay by the state, whether they are out or not. Every 2 weeks they get their paycheck. Okay, so they don't have the incentive to actually dig deep. Anyway, that's not what we're doing today. Anyway, that's why sometimes they ask you clear agreement just to get you out of the case so that you can start with the next person. Anyway, long story short. Now, if the jury convict, reject HO. HO means that the defendant is innocent, and convict an innocent person. See, HO innocent, and they convict him or her. That means they rejected HO. They have committed type 1 error. But if the defendant is guilty and the jury say convicted him or her, they have made a correct decision. Yeah, decision. So that means they rejected HO, that is innocent, and convicted him. That means correct decision. Now, if the defendant is innocent and he was not convicted, they have also made a correct decision. Okay. Now, if the defendant is guilty and they did not reject HO, I mean, they did not convict him, they have committed type 2 error. So nothing is proved absolutely, except if you use the entire population, which is not possible in most cases. It's based on evidence they have. Question on this? This is basically what hypothesis testing is about. You tell, you collect data, you analyze, then you make a decision. Any question on this? Any question?
No.
Yeah. Now we can now that I've given you this barrier, let's see how we can test hypothesis. Remember, sorry, how we can state hypothesis. Remember that for null hypothesis, you can only use equal sign or less than or equal to, or greater than or equal to. And for the alternative, you can only use not equal to or greater than or less than. Let's see how this works. Maybe three or four examples might help us understand this better. Okay. It says state the law and the alternative hypothesis. Look at this here. It says solution. It says here there is such a thing that if the expectant mothers use vitamin pills, the birth weight for the babies will increase. See, the birth weight will increase. That's a keyword right there. So increase means greater than. See? Now, but the average birth weight for the population is 8.6. So let us, so I usually advise students to start from the keyword to state the hypothesis, H1. Now, this, the average birth weight is 8.6 pounds. But this researcher thinks that it will increase if the expectant mother takes some vitamin pills. So let's start with that keyword. The birth weight will increase. See, we increase means greater than. So that means it will be on the alternative. That's the only place we can use greater than symbol. So we have that the mean average birth weight will be greater than. Okay, sorry, my mistake. The mean will be greater than 8.6 pounds. And that is what he's claiming, his claim. So the opposite of the claim that it will be greater than or equal to, it will be less than or equal to, I mean to say. Okay. So that means here that the mean, so you still the opposite of, say, the opposite of greater than is less than. But because you cannot use less than in the null hypothesis, you use less than or equal to, excuse me. So we have here that mean is as average birth weight, maybe less than or equal to, excuse me, maybe less than or equal to 8.6 pounds. Question on this? Any question?
No.
It's easy, right?
Yes, it's easy.
Let's look at the next one. Say that an engineer claimed that the mean, excuse me, let me put this one, that the mean number of defects can be decreased in a manufacturing process for compact disk by using the robots instead of human beings. So the mean can be decreased is the keyword right there. Can be decreased. So decrease means less than. And the only place you can use less than is in the alternative. Now, but prior to that, the mean number of defects is in 1,000 disk is only 18. So you can have it in this form, HO, like I said, start from where the claim is to state, solution. So start from where the claim is to state your hypothesis. HO and H1. You see that the mean number of defective disks per 1,000 is only 18. So, but he said that it will be decreased. See, keyword decrease, the keyword. So it's gonna be mean less than 18. I'll see less than right here, 18. That's his claim. That's 18 per 1,000. And the opposite of this would be greater than, but you cannot use greater than in the HO. So we're gonna use the greater than or equal to. P mean is greater than or equal to 18. Now, I want you to know that if you look at the two examples I just gave you, the claim was in the alternative. It's not always the case. Sometimes it will be on the null, you know. Now, this is hypothesis test for the mean, how to state this. So when it is in this form, look at the first one. Mean is greater than. Greater than is on the right side. We call it right tail test. Excuse me. Excuse me, class. Hello, sister. Good morning.
Good morning. I just read what you wrote, Naina.
How much you guys want me with class?
I was
So how much you guys? 3 hours. Sorry about that. I have to use an important call. Anyway, if you look at this greater than, you see that it is pointing to the right side. So we call this right tail test. Now I'm to figure out whether it is right or left. Look at the where the claim is. If you look at the example I just said here, this one is still less than 18. So it's the symbol is pointing to the left side. So that means a left tail test. Okay. Yeah. So now sometimes it might be two sides. In that case, we call it two tail. And I'll show you an example of that here. So look at it. This person says a psychologist says or feels that playing soft music during a test will change the result. It said we change the result. It didn't say whether it will go back less than or greater than. You said you change it. The psychologist is not sure whether the grade will be higher or lower, but it will change. In that case, changing, again, start where the claim is, HO and H1. So we change the result is the keyword here. Change. It didn't say increase or decrease, just say change. That means it can be both sides. So that means HO is mean. We have mean equal to 73 scores. So the mean, because you see that in the past mean scores is 73, which is the claim. Okay. Then the alternative. Now, sorry. Now the opposite of this is not equal to. Oh, sorry, my mistake. You say change. That means it's going to be not equal to. Mean is not equal to some. That means it's going to change. It doesn't know whether it change, it will be decrease or increase. H1 will be mean equal. That the opposite. You can use the equal sign. Mean is equal to 73. So because it can be on the either less than 73 or greater than 73, we call it two-tailed tests. Okay. Any question on this? Any question?
No.
That means you are still.
Somebody said something. What to do? Did you ask a question? Miss Owotutu, did you ask any question?
No question, sir.
Good. Now, I think let me show you where sometimes the claim might be in the alternative. Let me see. I have many examples here. Now let me use this one. Since we are not doing proportion, so I'm gonna leave proportion alone. Let's use the one that says here that look at number 6. It says the average income of accountants is 51,490. So solution is the keyword there. Is means equal. So that's where the claim is. We'll say is. So HO is that the mean is, remember, start where the claim is. The mean is equal to 51,497, which is our claim. See, in this case, the claim is in the null hypothesis. So the opposite of that is that H1, the mean, okay, mean is not equal to 51,497. So this is how to state hypothesis. Like I said, we'll be doing it only for the mean. So now, having explained that, I will now take you to some of the terms we use in hypothesis testing. For the terms we use, we have what they call the type 1 error and type 2 errors. I have already explained that already. Now, but the probability of committing type 1 error, we call it alpha. I mean, if your alpha is 5%, that means your chance of committing type 1 error is 5%. Just like we did in confidence interval, that means your chance of being wrong is 5%. If your alpha is 1.01, that means your chance of being wrong is only 1%. Or your chance of committing type 1 error is 1%. So we call it the significance, level of significance, the chance of being wrong. So we use alpha to represent that. Then critical region and critical value. Critical region is just like we call it the rejection region. And So I will explain what I with a 2-tail and 1-tail test. Now the value, critical value, is the cutoff value. Anything that falls from that value, up or down, you reject. So just like in a credit score, you can say, okay, if some loan application might say if your score is up to 650 or 700, then you approve you for the loan. Anything if the cutoff is 700, then if you have 699, they won't approve you. So just like that. So this cutoff points are the critical region and critical values. Let me show you with a 2-tail test. So the type of test we have. I've already explained 1-tail left test. Let me show you with a 2-tail test. Suppose 2-tail means that it's on both sides. Okay. So we have it in this form, a 2-tail test. Okay. And see? Then you have this here. Then it could be on the left side. Okay. Then on the right side, because it's 2 tails. 2 tails, it says 2 tails. So let's share the 2 tails, and this is too close. I'm gonna move it a little bit. Okay. Right. So now we can shed both of them. Okay. Okay. Okay, this is not moving. Okay, I'm gonna move it a little bit. Okay, good. Because this thing, when you use the hand, it's easier to draw, but when you're using a mouse, except if you're good with computer graphics, so this is can be challenging to shed it. So I'm gonna shed all of them. Okay. Now we have this on this side. If you're using a pencil, like in the classroom, it's a piece of cake. So, and do the same on this side. Now remember, this is a symmetric drawing, normal distribution. So it's metric where what you have on this side, you have on the other side. Now, of course, you have a mean of 0 at the center always. Now, okay. Okay, that's same. Good. Now, we have the critical reject HO reject HO. Then on top, I'm gonna write like here. Do not reject HO. And I'm gonna explain that. Now, so you see the side, so this is the center. This place is the acceptance region. Anything that this is the critical value, critical region here. Critical value is the number here, where the cutoff point. Now, who is Titigun? Titigun, who's he? Titigun. I don't know. Anyway, now let me put the arrow to show you. This is for anything that fall, any answer that fall in this group, you reject HO. See, any answer that fall in the critical region, the shaded place, you reject. But any answer that does not fall that and fall in this place, you don't reject. See it? So these are the critical region. The shaded part are the critical, and because it is on 2 sides, we call it 2-tailed test. Okay. Questions? Any question about this? And who is TT Goon? So I can know what the name to check here. TT Goon, who are you? Hello? Let's see. Yeah, I think he okay, I think he left. That's why. Okay. He joined briefly and then left. Anyway, now let me show you for left tail test. So one tail test can be on the left side or can be on the right side. So for that one, we have it in this form. I'm going to draw the chart again, okay, to show you the left tail test or how a one tail test looks like. Okay, then put this here. Then at the center, put this right here. That's for the the mean at the center. Now, if this is one tail test where it's on one side, okay. Now, let's say this one is the left tail, okay. If it's the right tail, it will be on the right. The tail will be on the right side. So let us share it, okay. And then share the rest of that just like we did on the other one. Sharing is the only difficult part when it comes to hypothesis testing. The other part, even though they involve calculations, if you really get the hang of it, you see that actually it is fun. Sharing is only difficult if you are sharing it where I'm doing it with a mouse. If you're using hand, it takes a while. And also there are some graphing tools online that you can use for shading. But the problem is that if I use them, you might not know why some places are shaded. Also, there are so many advertisements there that keep on encroaching on the work. So that's why I decided to do it the old school way. Now, see, you can see that only one side is shaded. The left side, we call this one tail test. So because it is the left side is shaded, we call it left tail test. If it is the right side that is shaded, we call it right tail test. So here is a reject HO. So let me say reject HO. Now in that case, it is on the shaded region. So this is where you're gonna reject. Okay. These are the critical region. So the number here is called a critical critical value. That's the cutoff value. But so any answer you fall in that value or on the critical region, you reject. Now, I want to say do not reject. Do not reject HO. HO. That means in that case, it fell in the acceptance region. Okay, that means it fell here. See, without reject. Now, for this one where you have two sides, this is how we state the hypothesis. HO maybe mean equal to K. Mean equal to K, where K can be any number. And H1 mean are not equal to K. See, where K can be like one with it can be 8 pounds, it can be 20,000. So, but this is whenever you use equal and not equal, it is a two-tailed test. But here, there's only one side. In that case, the way you state hypothesis will be this way. HO have mean equal, well, we study where we say this is say on the left side, that means it's gonna be less than or equal to. So it can be some books might say mean less than or equal to, okay. Then H1 can be the opposite, mean, okay, greater than, because you cannot use the opposite of less than or equal to is greater than or equal to, but you can't use greater than or equal to in the alternative. So you gotta use only the greater than symbol. Okay. Now, some textbook might say use it, do it this way. You can say because of the definition of the null hypothesis, that it say that population parameter is a particular value. So some textbook might say use this form, mean equals to k, and the alternative, because it's on the left side going left, so gonna be mean H1 can be mean greater than, say mean greater than, okay. Now, why I use this, it depends on where the claim is. If the claim is in this place, it's gonna be the opposite. Like if the claim say like less than, that means this will change to less than, and this will change to greater than or equal to. Any question on this? Any question?
No.
Good. Now let us now do one test at least, and take a short break. Come back and finish everything. Okay. So like I said, we focus only on the Z test for the mean. We're not going to do proportion. So look at this, the rules we've used. State the null hypothesis and identify the claim. I have shown you how to state the hypothesis. Find the critical value for the appropriate table. Compute the test value and make decision. Now, before we do that, I'm going to tell you this. There are two methods we use for testing hypothesis. Two methods we use. Two methods for testing hypothesis. One of them, the one we're about to do now, is the traditional method. In that case, we use the critical value as our, rejection criteria or decision criteria. There's another one is the p-value method. We're going to do both of them. Okay. Now let's start with the traditional methods. See this one, the p-value method we use. P-value simply means probability value. The value of the probability. Okay. Now, for the traditional method, we go these steps: state the null hypothesis and identify the claim, find the critical value, because that's what you're going to be using for our decision, and compute the test value. That is run the tests. When we say compute the test value, they say that means find the test statistic. That's another way of saying it. Or calculate the test statistic, and make a decision. Now, how do you make the decision? This is the criteria. Okay, decision criteria. Okay. Now, we reject null hypothesis if and only if our answer, that is the calculated value, is bigger than the critical value. So we get the answer, we find our critical value, we keep it, we do our test, and then compare it with the critical value. If our answer is bigger than the critical value, we reject null hypothesis. If it's less than the critical value, we don't reject it. If the answer is equal or bigger than the critical value, we reject. If it's not, we don't reject. Now let's do this test here. It says say a researcher report that the average annual salary of assistant professors in the year 1997 is more than 42,000 a year. So a sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, tests the claim that the assistant professors earn more than $42,000 a year in 1997. The standard deviation of the population is 5. So they say that for the population, they say that the average salary in the year 1997 was $42,000. Now, they collected a sample of 30 of them and found that the average salary is 43,000. So somebody might say, okay, the average for that 30 is 43,000, is 43,260, which is bigger than 42,000 already. So why are we doing the test? Is that the average already tell us that it's bigger than that? No, the average is for the only 30 professors. It didn't tell us the entire population of assistant professors. So that's why we still need to run the test. Okay. So it gave us because there are so many instances where something is true for a small sample, but when we make it generalize it for the entire population, it will not be true anymore. See, that's why we want to run the test. So now it says test the claim that the assistant professors earn more. Earn more here is the key. Earn more than, that means greater than. See, that means bigger than. So that will help us to test the hypothesis. Solution. And this is the traditional method where we use, the critical value for our decision. So HO and H1. We got H1. Okay. Now, he's saying that the annual salary, the claim was that there's less and more than. Okay, see more than here. So that means HO, that mean is greater than that amount. So HO, okay, HO, right here. Always start from the claim. Mean is, you say more than, that means greater than. $42,000. $1,000. That's where the claim is. The alternative, well, sorry, the opposite of this null is always the opposite of the alternative. So HO, the opposite of greater than is less than, but we can't use less than symbol in the null hypothesis. So we're gonna use the closest symbol, which is the less than or equal to. Mean is less than or equal to $42,000. Okay. Now it said at alpha 0.05. So that means your chance of being wrong, this is your significance level. The chance of being wrong is only 5%. Alpha 0.05. So that means we need to find the critical value. Now, because it says greater than, that's its right tail test. Right tail test. So we find the critical value and the critical region. So I'm going to draw the chart so you can see how it will look like for a right tail test. It's a greater than. So our curve will be in this form. Okay. Okay. All right. Okay. So and it's gonna be from here. Of course the mean standard for mean is gonna be on this side, and you say greater than C. It say greater than C. You're gonna be on the right tail. So I'm gonna put this on the right tail, and okay. Then you can now put your shading. Okay. Shade the right tail. This is the part that slows us down a little bit. I'm still learning how to draw with the mouse. Look, there's so many, you know, this Microsoft packages have even painting. I don't know how they do that with the mouse, but there are people who are so good at it. I'm just, you know, want to use this to show you, but it's always easier for me to draw this on the board with a free hand, but COVID-19 won't let us do that. All right, we have this. So this is where you reject the shaded place. If you answer 4 in this shaded region, reject. So this is, you see, that's how our distance will look like. This is 0 here for the mean. So let us find the critical value. Critical value will be right here. So the critical value now becomes, I will have, what is the critical value? Because this is traditional method, we're going to use critical value. That's rejection area. So critical value means Z critical, Z critical. Now remember what I told you when we are doing a normal distribution. When it's at the tail, whenever it's at the tail, you do before I explain that, 0.5 minus whatever answer you get from here. Now, let me remind you about the statistical table we'll be using. So I have this already in the canvas for you when we are doing a normal distribution. We'll be using table 4, table of standard normal distribution, area under the standard normal distribution. You can see that. I hope I'm sure you can see it. Yeah, that's the table we'll be using for getting our critical value. So to get our critical value, we use this table. Now, this table, there are 2 types of it. There's one that is cumulative. That's the one that I have not. This one is not cumulative. I have already explained this to you before in my previous lecture in normal distribution. So if you're using this type, and then it means that anything that falls in the tail, you follow the step I'm explaining here for us. Now, if you're using the other type for table, it has different rules. You have to use that rule. But if you use that rule very well, you get the same answer that we get here. Okay. So to find the critical value, the question says that our alpha is 0.05. Now, if you're using, if it is a 2-tailed test, you get the critical value the same way you get for the confidence interval, or you can use this method. It doesn't really matter. So 0.5 minus 0.0500, and that will give us from the. I'm going to take you to Desmos calculator so you can get 0.5. 0.5. Oh, sorry, excuse me. Minus 0.05. How do we get 0.05? Because you see that alpha is 0.05. So you get because it's 0.05. That means 5% significance level. 0.45. So we're gonna put it here. 0.45. 0.45. Now, because all the numbers have to be 4 digits, so 4500. Now, you look for this number in the table of normal distribution to get the critical value. You look for it. If you don't see exactly this number, then you choose a number that is closest to it. Okay. Let's look at it. So I will take you to the table here. 0.4500. So have 0.45. I found 2 numbers here that are close to it. I have 0.4495 here. Let me write it down so that I can't. What is my paper? I need paper for this. Okay, good. Got it. So 0.45, 0.4495. Then another number that is close to it is 0.4505. 4505. So the number we have we're looking for is 0.4500. So let's say which of them is closer to it, closest to it. I will say back to Desmos. I got I clear this. 0.4500 minus 0.4495. This scientific form might confuse you. So just because all the numbers have 4 digits, so ignore the decimal point. Just get it that is the decimal point. Just 4500 minus 4495 is 5 points away from the number. Okay, remember that our number is that we are looking for is 4.4500, which we just write as 4500. So the first one we find is 5 points away from it. So let's check the second number we find in the table. The second number we find in the table is this one, 0.4505. Now we can check it in decimals as we have clear this 4505 minus 4500 is also 5 points. So the two numbers are equally close to it. So when this happens, we choose the bigger number of the two. Okay, the bigger of the two. So that means we're gonna choose this one here. Then we follow it to the left. It is 1.6. Now we follow it up 5. See, if you follow it to the left, it is 1.6. If you follow it up 5, that means 1.65. So that our critical value is 1.65. Okay. Now I'll take you back so that we can now run the test. So then when you're using traditional method, what you do is to get the critical value first. So you're gonna, this is 1.65, 1.65, which we can write here as a critical value, say 1.65. So if we run the test, if our answer is bigger than 1.65, we reject HO. If it's less than that, we don't reject it. Okay. So now we're ready to run the test. Remember the question says that the annual salary is more than 42,000. So our mean, let's put the other variables, then run the test. So the mean equals $42,000. And then you say that the standard deviation is what again? Oh, they have a sample of 30 and assistant professors. So to check it, so the sample size is 30. And for these 30 assistant professors, they find that the mean average salary is for that year is 43,260. Now, we don't have sample mean character here. So I'm going to open a Word so we can go there and get the character for X bar. I call it sample mean is X bar. Okay. When I open it, I'm going to share it with you. So then, before then, let me say that we say that for the give me 1 minute. Okay. And then for the our question, you said that for this sample mean of 30, for this sample size of 30, the average salary is that's our X bar, mean is 42,000. And for that sample, X bar is 43,260. Okay. So let's go to that other workbook and get the character for X bar. We have X bar. Have X bar sample mean. Okay. X bar. Let me make it bigger. I need to make this place bigger. Let me give me 1 minute. Let me push this up. Okay, so you can see it. Okay. Equals 43,260. So I'm going to copy it from here and paste it in our main workbook. Okay. The main workbook right there. So you see 43,000 for them. So we got to put it right here. 43,000 for X bar. And the standard deviation they give us was they give us standard deviation of 5,260. So I'm gonna copy it from here. 5,260. Good. Close this. 5230. So standard deviation is the symbol right here equals 5230. 5230. This always change to data symbol each time I use it. So let me change it back to what it should gonna be. For standard deviation is this. Is that okay? Make it bigger. So we're gonna run the test. So we have all the values they give us that we need for the test. The population mean their salary in the 1997 for the 2000. Then the salary now, I mean, for the sample size of 30s for the 3,260, and the standard deviation is 5,230. So with this, we can run the test. Let me write these numbers down. I have mean is 42,000. Sample mean is 43,260. Standard deviation is 5,230. So the test statistic for Z test, I'm going to write it down and then we do it. I will take you there is test statistics. Let me take you to that workbook where we can get this formula and then put numbers in. Okay. The test statistics in this from Z. I'm gonna make this bigger. Okay. Make sure you're seeing it. Yep. So it's Z, which is the Z test equals the sample mean of X bar. Okay. Something of S bar minus the population mean mu. Okay. Divided by standard deviation over the square root of n, root n, so root n. So we have it in this form. Our sample mean, I wrote it down. We have it on the other page, on that workbook. Our sample mean is 43,260. And the population mean was 42,000 divided by standard deviation of 5,230 over square root of n. Our n is, they selected a sample of 30 assistant professors. So our n is 30. Equal. So now we can go to decimals and get. So this is the test statistics right here. X bar minus mean over standard deviation over root n, where S bar is the sample mean, mu is the population mean. We have seen all this symbol before. Delta is the standard deviation and n is the sample size. That gives us this. And all these things that I mentioned, we have them here. We have them in the main workbook. You can see the mean is 42,000, n is sample size of 30, Now let's go to Desmos and get this done. So I'll take you to Desmos. Okay. So we can run this test. So we have sample mean is 43,260 minus population mean is 42,000 divided by standard deviation, which is 5,230 divided by the square root of 30. Okay. So have, excuse me, give me 1 minute. Let me get something here. I need to check on something. 1 minute. Oh, got it here. Okay. All right. So so your answer is 1.3195, but normally we round it to 2 decimal places, 1.32. So I'm gonna take you to that workbook and put it at 1.32. 1.32. So we gotta copy all this. We have run the test and get the answer as 1.32. So I'm gonna take you to the main workbook and paste it there. 1.32. 1.32. We can now make our decision. So, decision. Remember the criteria for this decision. You say reject null hypothesis if the calculated value exceeds the critical value. So if your answer is bigger than critical value, you reject null hypothesis. So our critical value was 1.65. Critical value equals 1.65. Okay, that is our critical value. But the calculated value, our calculated value, that's our answer. Calculated value is 1.32. So our answer is less than the critical value. So we don't reject. So do not reject HO because our answer, which is 1.32, the calculated value or answer of 1.32 is less than. So it's less than the critical value of 1.65. So because of that, so if you look at the rejection region, you can see that this 1.65, 1.32 is less than that, it will fall in the acceptance region. So we did not, because we did not reject HO. So this claim, if we don't reject this, that means we are saying that this one is not correct. So that means that leads us to the conclusion. So conclusion. Okay. Now again, we did not reject the null hypothesis because our answer is less than the critical value. So we don't reject this. So this claim is not correct. So that we say that we can say that the claim is incorrect, or you can just say that they are. No, why I want you to use this one I'm writing now is that if you look at the example I gave with the jury system, that you convict, that's not all. It means that there's enough. There wasn't enough evidence to convict. Okay, so there is insufficient evidence to support the claim. And what is the claim? The claim was that they make more than 42,000 a year. That the average salary and the average annual salaries is more than that amount. That the average annual salary is more than 42,000. See? So again, you state your hypothesis, draw your charts, get your critical value. Then you from the equation you get the numbers for population mean, sample size, sample mean, and standard deviation. Then use this formula here to run the test. to get the answer. When you finish the test, you write the critical value out, write your answer and compare them. If your answer is bigger, you reject null hypothesis. But in this case, if your answer is less than the critical value, you don't reject. So you make the final decision, conclusion based on whether you reject or not. This is what hypothesis testing for the mean is. Any question for me? Any question, class?
No.
Good. So let us take a short break. We're coming back here, 10 minutes break. We're back here 2:32. Okay? 2:32 p.m. So enjoy your break. I'll see you back here in just 10 minutes. Okay? You agree or not?
Yeah. Okay. We'll see you back at 2:32.
Yeah, sure.
Yeah, that's fine.
All right, I'll see you then. Yeah. Let me round up this. Let's finish up and then Hello.
Yes, Professor.
We're back, eh?
Yeah.
Let's finish this. So now I've shown you how to do the traditional method. So now we have the chance to try the rest by yourself as a practice. Now let me tell you something more here. This one says a researcher claimed that the average cost of men's athletics shoe is less than 80. So let me give you the hints. This is less than, that means you gotta use the less than equal, sorry, less than symbol. See, that's so the claim is on the alternative. Now here it says the Medical Rehabilitation Education Foundation reported that the average cost of rehabilitation for stroke victims is 24,670. So this one tells you that it is two tied. Say is. Now look at this. It says, can it be concluded that the average cost of rehabilitation at a particular hospital is different? So is different means that it can be less than or it can be greater than. So that's why you call this one. This one is a two-tailed test, but this one here is a it says less than that, so it's going to be left tail test. So, but it's the same process that we just did here. Follow the same process. State the hypothesis, identify your claim, draw your chart, find your critical value, then run the test. Compare your answer to the critical value. If your answer is bigger, you reject Null Hypothesis and make a decision. If the answer is smaller than critical value, you don't reject and make a decision. So I encourage you to practice those following the example we did today. Let us do the p-value method. So the p-value method. The p-value method is still basically the same thing, except that here we don't need the critical value. We only need the p-value. Okay. So if you look at the working rules, you can see that it's still the same thing. State the null hypothesis. Sorry, state the hypothesis and identify your claim. Compute the test value. Find the p-value. Make a decision. Now, the decision criteria for p-value is different from the critical value, but at the end, we get the same result. Now, for critical value, if your answer is bigger than critical value, you reject, but not so in the p-value. In the p-value method, if your answer is less than the p-value or equal to the p-value, you reject. Now, if the answer is greater than the p-value, you don't reject. So it's the opposite of the critical value method. I mean, the decision criteria. Let's do it. Let's try one example here. It says here that a researcher wishes to test the claim that the average age of lifeguards in Ocean City is greater than 24 years. She selects a sample of 36 lifeguards and finding that mean sample of 24.7 years with a standard deviation of 2 years. Is there evidence to support this claim at alpha 0.05? Now remember, it says use the p-value method. Now p-value simply means the probability method, probability value. So let us start by solution. Okay. Let us take the hypothesis of HO and H1. Normally you start from where the claim lies, okay? Don't forget that. It's always better to start from where the claim is. Now, HO, so it says here, is there evidence to support this claim? Okay, the claim was that the average age of lifeguard in Ocean City is greater than, so that's the keyword there, greater. And the greater than symbol can only be used in the alternative. So we can now put the part first. Mean is greater than 24 years. Say 24 years. 24 years. Okay, this is a claim right there. And the null hypothesis will be saying the opposite of that. So the opposite will be that mean is less than that. But we cannot use less than symbol in the null hypothesis. So we're going to use the closest symbol, which is less than or equal to. So that mean is less than or equal to 24 years. Now, some textbook might say just write mean equal to 24 years. Some textbook might say that, and then opposite. Now, our alpha is 0.05, so that our alpha is 0.05. Move right here. Okay, alpha is 0.05. 0.05. Each time I don't know why it keeps changing to something different, but let me write it back. Alpha. I think it's because alpha is actually means A in the Greek. I don't know. All right. So let us get our values and calculate the z value. So now for the p-value method, we don't need to find the critical value. We find the p-value. So let us run the test so we can calculate the test statistics so we can get our p-value. Okay. So before then, let me show you how the chart will look like. It's gonna be okay, in this form. Yep. Let us not draw the chart first because this one is a little bit different. Let's draw the chart later because of the fact that so we have our mean is 24 years. So I'm gonna put mean equals 24 years equals 24 years, and sample size n equals I say 36 lifeguards. And for that sample, you have mean of sample mean. Now, the sample mean character symbol, I can't get it from here. So let me take you to where I can get it. Sample mean symbol of X bar is 24. I think it's 24.3 years, right? I think. I wrote it down somewhere here. For the p-value method. There are 24.3 years. Oh, 24.7 years. Okay, so I'm going to copy this from here. And then put it in our main workbook. 24.7 years. With a standard deviation of 2 years. So we have our symbol for standard deviation right here. 2 years. Okay, it changes back to that again. So I'm gonna 2 years right here. Now okay. So let us calculate this, run the test so we can get our p-value and then compare. So the formula, we have everything we need to write the formula and get the test statistic. So I have mean is 24, sample size is 36, standard deviation is 2 years, and the sample mean is 24.7 years. Now, let us run the test. I will take you to that page, other workbook, so we can now put our formula in and find the table. So it's the z equals, like before, the sample mean, okay, the same formula. The sample mean, X bar minus the population mean, mu, okay, divided by the standard deviation over square root of n, where n is our sample size. Okay. Now plugging in the values we have. Excuse me. Plugging in the values we have. I have the sample mean as 24.7. 24.7. Population mean of 24 years divided by standard deviation of 2 years by the square root of 36, because 36 of them samples we are selected are 36. Now this we can now go to the decimals to get this information out. I'll take it to decimals. Okay. And then clear this. So sample mean of S bar 24.7 minus population mean of 24. I'll close this, divided by the standard deviation of 2 over square root of 36. Okay. All right. It's 2.10. 2.10, you can see right, 2.10. So I take it back to the our workbook. 2.10. So with this, this is our Z value, the test statistic. With this, we can draw our chart and then find our P value. So I'm going to take you to the main workbook and put this work in. So we can now draw the chart. So this is the answer we got from that calculation. I'm going to move it down a little bit so we can see right here. So our Z, so let's make our chart. Insert. Okay. 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 Now we have it in this form. Pick this and then the x-axis. We have the mean of 0. Okay. Mean of 0. So what I'm going to do is to move this up a little bit. Oh, I can go beyond this. Okay, so I'm going to move this. Move it down. Put it that way. Move this one down. Okay. And bring this one down. And then, okay, that's better. Okay, it says that the average average age of the lifeguard is greater than 24 years. So it is no longer 24 years now. See, sorry, it's greater than 24 years, but it says for the sample, we have a sample size of 24.7. So it is no longer 24.7, it is now 2.10. So we have it here. So continue with the shape, we can finish the drawing here. This is 2.10. This one is 0. This one is 2.10. Okay, then we can, share it. It's right here. So put the share right here. And then this one here. Now, okay, now we have found our numbers. So let's find our p-value. Now, the p-value, okay, becomes have 2.10. Find the value of 2.10 on the table. Okay, 2.10 have 2.10 when it is, if you remember what I told you, when it is on the tail like this, you use and if you're using the table that we are using this class, you're gonna do 0.5 minus the answer you get for 2.10. That's a 2.10. So let's go to the table. 2 under 1. 2.10 means 2 to see z 2.1 under 0. See? 2.1 under 0. You see right there. See the 0 right there. So it's 0.4821. That's it. 0.4821. So you go here and put okay, 0.4821. So we subtract this from the calculator. So 0.5 minus that. I'll take it to Desmos. So we'll get our computation. Desmos says here 0.5 minus 0.4821. 0.821. Give me 0.0179. You can see this right there, 0.0179. That's their p-value right there. I'll take it back. 0.0179. Now we're ready to make our decision. Okay. We have okay. The critical our p alpha is 0.05. Let me copy it. Alpha is 0.05. Then p-value is 0.0179. So look at the criteria to reject or not. It says if the p-value is less than or equal to alpha, reject. If p-value is greater than alpha, do not reject. So here, our p-value is less than alpha. Say, reject null hypothesis, HO, because our p-value of 0.0179 is less than the alpha. Is less than alpha of the alpha is 0.05. So that means we are rejecting. Remember the claim was that the average age is greater than 24. That's our claim. So we rejected this, the null hypothesis. That means we are accepting the claim that it is correct. So that our final decision, conclusion, now become conclusion that the claim is correct. Or you can say that there is sufficient evidence to support the claim. That, okay, what's the claim again? That the average age of lifeguard in Ocean City is greater than 24.7 years, is better than 24.7 years. That's our final conclusion. The average, the claim is correct. You can just write the claim is correct, or you can just, then you write it, or if you don't prefer, write it this way. The average age of lifeguard in Ocean City is greater than 24 years. Questions on this? Any question on this?
No.
Very good. So let us round up this topic for today. Let's round up with a test of hypothesis for small samples. If you notice, I'm sure you must have noticed by now that it's examples we are using before. The sample size is either 36 or 35. You know, the first one we did was actually 30 of them. So in statistics, with the sample size is 30 or more, we say it's large, not large, so long as they are selected at random. But in some cases, and also the examples we did before, they tell us the value of the population standard deviation. For example, here they say that in Ocean City, the average is 42,000. Then the standard deviation of the population is 5,000. So we know the standard deviation of the population. We also know that the sample size is large. But for small samples, and if we don't have no idea what the population standard deviation for the population standard deviation is, we use a different method. We call it the t-test for the mean for small samples. So we use this method when the sample size is small, and if we don't know the population standard deviation. Let me show you. Okay, I don't have it here. Okay. So when the sample size is small, we use t-test. T-test for the mean. Now, this is very interesting. T-test for the mean. You have a very interesting history. In the old days, before we have these many laws, labor laws, before it's like competition, very big competition among the all these big corporations. So that competition make them to get involved with so many sharp practices to get market, to corner the market for themselves. One of the things that they do is to hide their secrets, trade secrets. So if you're working for them, they don't allow you to publish and even any research you do with the company resources. Once I publish it openly, even they still do it now anyway. Now this guy, William Gozet, I think his name is Gozet. Let me see. Let me look. Yeah, it's Gozet. He did this. He was doing an experiment. How to make what they call, there's a drink we call ale. He worked for a brewery in Europe. I've not seen a lot of ales here. Many the ale I see in America here, they are usually non-alcoholic, but in Europe, ales, they are alcoholic drinks actually. So he was working for this brewery that make ale. So because they are not allowed to publish their findings because of the competition. So instead of publishing it with his name, which is Gozet, he published it with a different name. We call it student tea distribution, instead of using his name, Gozet, So that is how we started using it, the tea distribution. So let me show you how the tea distribution table looks like. I'll take you to the statistical table. It's right here. See the student tea distribution. Now, remember the time we did confidence interval, we used it too. But for the confidence interval, we are using only this one that have a double prime. Now, if our test is a two-tailed test, we use the a double prime. If it's a one-tailed test, we use the one at the top, a one single prime. Okay. Now, again, remember we use this when the sample size is small, and we don't know the value of the population standard deviation. That's when we use t-test. The formula is simpler, it's still the same, similar, except that now we're using t instead of z. and we'll be using a sample standard deviation instead of the population standard deviation. So let us do it. Let's do one example. Example says here, bigger. It says that a job placement director claimed that the average age, average salary, starting salary of nurses is 2,000. In the year 2000 is $24,000. A sample of 10 nurses salaries have a mean of 23,450 and a standard deviation of 4,400.
Professor,
yep.
Are you going to send us all this?
Yes, I will.
Thank you.
You know what? See, which reminds me, the last example we did was p-value, right? Right or wrong? Yeah, this is for p-value. Now, p-value this is for left tail or right tail. Now, if you're doing a two-tail test, then your p-value will be this answer you got here. You multiply it by 2. If you're doing a two-tail test, that will give you the p-value. So, but for the left tail or right tail, you just leave it the way it is. Okay, I just remember that. Yeah. Now, it says, if you look at this, sample size is small. That tells us that we can use the z test. That means we're going to use the t-test. When we are doing confidence interval, I showed you how to use the t-table. It's very easy. So first, so let's just state the null hypothesis and alternative hypothesis and identify our claim here. Okay, he says that he's claiming that the average starting salary for nurses is in year 2000 is 24,000. So H1 mean, you have this form, mean equal, sorry, is it greater than? Also, it says is. He claims that the starting salary is 24,000. So that means you're gonna put it. You can only use equal sign in the null hypothesis. So you're gonna have it here. Mean equals $24,000. A sample of 10 nurses, okay, has a mean of 23,000 and a standard deviation of 400. Is there enough evidence to reject the director's claim? The director's claim was that the average starting salary for nurses is 24,000. So that means the opposite here will be mean, not equal to 24,000. Not equal to 24,000 plus. Okay. Now, the standard deviation of the population. Okay, we have it here. And the alpha, you see an alpha 0.05. So I'm gonna just copy it from here. Alpha point, that means your chance of being wrong is 5%. 0.05. Okay. Now let us put down that. Now, like I said, I showed you how to use table of t-table when we are doing confidence interval the week before the Thanksgiving week. So we can just go and use it. Now, he's collected a sample of 10 nurses. So n equals 10 nurses. So that our degree of freedom, df is always n minus 1, which is 10 minus 1, giving us 9. So that we can now get our critical value, TC. TC, that's critical value, critical T from the table. Critical T, we go to the table and look under 9 degrees of freedom. Okay. Let me take you there. This is table of T distribution. Okay, T. Now, because it's what 2 tails, we're gonna use A double prime. Our alpha is 5%, so that's see right here, 0.05. See, this is DF, like I showed you 2 weeks ago. You go all the way to 9. It's 1. It's a 9. Okay, it's right here. 2.262. 2.262. So give me 1 minute. Let me open this page. Yeah. Okay. 2.262. So I forgot for alpha 0.05, 2.262. 2.262. So I'll take it back so we can put it in. 2.262. 2.262. Now, because it is 2 tails, remember this is equal and not equal, so it can be either way. That means the critical value will be plus or minus 2.262. So if your answer is negative, then you're going to use negative 2.262. If your answer is positive, you use positive 2.262. Okay. So now with this, we can make our chart here. Insert the chart. Say 2 sides. It can be 2 sides because there are 2. Okay. Okay. This is the chart right here. Okay. Then you have more this thing, the mean of it. Okay. Then right there, mean of 0. Then this one will be 2.262, 2.262 on the right side because it's 2 sides, 2 tails. So this one will be negative 2.262. Okay. You can now do the shading like we always do. So your answer can fall on the left side, or it can fall on the right side because it's of the 2 tails. Now, if you fall in any of these critical regions, we reject. Okay, negative 2.262. So when we compare, we use the absolute value of that. Okay, absolute value. If it's negative, you use the absolute value. So if your answer is negative, just use the absolute value of negative number is always a positive number. Okay. So if your answer is, if you get a negative answer, use the absolute value to compare. Okay, I think I got this one. On this side, right side, we also have the critical region on both sides. Okay, I have the critical region on both sides, this side here. Okay, I think I've got 3 more before we can get this done. All right. Okay. And then last but not the least. Okay, good. Now, we're ready to run the test. We have our sample size. So our sample mean is, population mean is 24,000. So we have our critical value. So let's list the numbers, the values we'll be using. The population mean, he says that it is, how much again? He says $24,000, 24,000. And the sample is 10 nurses, 10 of them. For this 10, the sample mean, since we can't get the character here, let's get the character for the sample mean from the other workbook. Here, S bar, equals, and it says, I think it says it says 23,450, 23,450, 3,450, 23,450. So I'm gonna take it to that place. Okay. Okay. To the main workbook. So 23,450. So I can make it bigger so that you can see it very well. And the standard deviation will be how many losses? Is have a standard deviation as $400. $400. Okay. It's not to change the data symbol again. Let me correct it. So let me make all this bigger. We have everything we need to do the run the tests now. So we can just simply run the tests and then make our decision. So now, like I said, so different now is that we're using the T table and we're using sample standard deviation and to calculate the test statistic, which is T. So let us do the test statistic. Let me write it down. T equals sample mean minus population mean divided by sample standard deviation over root n, which is this got 23,450 plus 24,000 divided by standard sample. Oh, and one more thing. We are using sample standard deviation, so our symbol will be S, not delta, because it's sample standard deviation. S of 400 over square root of 10. Okay. I'll take you to that workbook so I can put this in and then copy it, paste it back here after we get the results. So instead of Z, we use T equals we have sample mean, which is the X bar. Okay. X bar minus population mean of mu as before, divided by standard deviation of S, which is sample standard deviation over root n. Root n, which is the sample size. This gives us equals, we put our numbers in. We have 23,450 minus 24,000 divided by standard deviation of $400 by the square root of 10 losses. Now we can now figure this out in Desmos. Let me take you to Desmos so we can get our results. So we have 23,450 and now 24,000. Okay, divided by this standard deviation of 400 by square root of 10. 10 losses. Negative 4.3481. So just choose two decimal places. Negative 4.35. Right now. Negative 4.35. So I'm gonna use it to the workbook and from there to the main workbook. Negative 4.35. So for in absolute value of this, absolute value of this is equals 4.35. That's what we're gonna use, 4.35. Negative sign is just to tell you that it is on the left side, that's all. Okay. So absolute value of this is okay. So I'm taking it there. The main workbook. So I'm gonna paste this here and you see our results. So we use the absolute value of, so you can see that clearly 4.35, see the critical value is negative 2.6, so negative 4.35, 4.354 in the rejection region is bigger than this, 2.62, okay? Oh, actually, we're using the absolute value, sorry, my mistake. Absolute value 4.35, see, 2.6262, it falls here, it falls. Even though the negative sign is on to show it on the left, I'm using this side to make it more clear to you, okay? If you want to use negative 4.35, you get negative 2.262 before you can get negative 4.35. It's still far away on the left side. It's still far in the rejection region, okay? Now, let us make our decision and conclude decision. Critical value, a critical value. Critical. Okay. Critical value is 2.262, negative 2.262. Why are we using negative? Again, like I said, this answer is negative. That's why we're using the negative side. You can see that it's still far in the negative side, get far away from this, but it's far in the rejection region. If you want to use the positive side to get the answer, you can just get the absolute value. In that case, it's still far here. Okay. Then critical value, sorry, I'm not critical. Calculated value. Calculated value is negative 4.35, which is, like I said, still, if you check the absolute value, it's bigger than this, okay? So we still reject HO because the absolute value of our answer of negative 4.35 is greater than okay, is greater than, and the absolute value of negative 2.262. See, the absolute value I mean to say. That means that was saying that 4.35 is greater than 2.262. So that's the absolute value right there. So the final conclusion is conclusion is conclusion. So we reject HO. We rejected it. So that means he's saying that the average starting salary for the nurses is 24,000. So that is equal. So our claim is here. Claim is right there. So that means since we rejected it, that means the claim is incorrect. So you can say there is insufficient evidence. There is insufficient evidence to support the claim that the starting salary of these nurses, the average starting salary for nurses is 24,000. Okay, that's our conclusion. Now, like I said, always try as many examples as you can. Now, this example here, they just something, except that here they give you the numbers. In this case, you have to calculate the mean by yourself, calculate the standard deviation, and then follow the same process. So it's basically the same thing. So calculate this mean. So when they give you a list of numbers, just find the mean, find the standard deviation, then follow the same steps. For the proportion, we are not going to do that. And I'm not going to ask you any question on proportion, on the Z test for proportion. Any question before we leave? Any question before we leave?
Are you gonna post this class?
Yeah, I'm going to upload it because it is recording right now. So as soon as I finish recording, and then I'll upload it for you so that you can always watch it when you want. Okay.
Okay.
Any more questions?
No.
In that case, I'll see you next weekend. Enjoy your weekend there, okay?
All right. Enjoy your weekend as well.
I'll try.
Okay.
Okay, bye-bye.